This is a lesson on parts of the atom. Three parts of the atom: protons, electrons, and neutrons. Protons are things that determine the identity of the atom. Carbon has 6 protons, and if it has 6 protons, it must be carbon. So the number of protons tells you what the identity of the element is. So if it's carbon, protons must be 6. If it's not carbon, if it's not carbon, it won't have 6. It's uranium. Uranium has 96 protons. If you have 7 protons, then it's going to be nitrogen. So you can determine what atom it is. The number of protons is also equal to the atomic number. The atomic number is the number of protons. It's the ranking of the elements from 1 to 116, or whatever the latest element is going to be. If you have carbon, since it's 6, the symbol will be this. If it's a generic X element, the subscript to the left is going to be P, the number of protons. Okay. The electrons determine if you have an atom or an ion. If it's an atom, a neutral atom, that means the protons must equal to the electrons. So the protons equals the electrons if it's an atom. If it's an ion, that means you're going to have too many electrons or too few protons. You can't change the number of protons, it's the number of electrons that's changing. So if you have an ion, you're going to have a charged atom or a charged particle, and the charge on that particle will be the number of protons minus electrons. If the number of protons is 17 and the number of electrons is 19, 17 minus 19 is a negative 2. That means there are 2 more negative electrons than protons. If the number of protons is 17 and the number of electrons is 16, 17 take away 16 is plus 1. That means there's going to be 1 additional positive proton compared to the negative electrons. If you put the charge in, the charge is up here, P minus E. Down here, P minus E. This is going to be some number, say 2 plus. There are 2 different ways of having ions. You can have anion, which means you have more electrons, so it's a negatively charged. You can have a cation, which means you have fewer electrons than protons. You're always changing the number of electrons, you're never changing the protons, because that would give you a different element. You have fewer electrons, which would give you a positive ion. Neutrons With neutrons, these determine the isotope. An isotope is two atoms with the same number of protons but different number of neutrons. Some isotopes are radioactive. They are radioactive if you have too many or too few neutrons in the nucleus. Even though neutrons are neutral, they're the things that keeps the two positive ions. Remember, positives will repel, two positives repel, opposites attract. So if you have two protons in a nucleus, they would want to fly apart. What happens is these neutrons supply the weak nuclear force, which keeps the nucleus together. And you gotta have it balanced with being charged, with having no charge. So you gotta have too many or too few neutrons, you got radioactivity, and part of the nucleus falls apart, which means you got different elements being produced. Isotopes have chemical properties, the same chemical properties. So different isotopes of the same element have identical chemical properties. It's just that they react at different rates. The heavier isotopes will react slower. The lighter isotopes will react faster. And this is just like fusion and diffusion. The weight of the particles makes them move more or less. Also with the neutrons, we got to worry about the mass number. The mass number is the number of protons plus the neutrons. One proton is the same weight, almost, not quite, as one neutron. One proton, one neutron. Neutron's a little bit heavier than that, so they're equal to the size, and they are defined as 1 AMU, which stands for atomic mass unit. Atomic mass unit is invented, and it's a nice thing because it gives you the mass. So the molar mass numbers, like for helium, the molar mass is 4 grams per mole. It's also 4 AMU. So a mole would weigh 4 grams, a single atom would weigh 4 AMU. So this is a good thing because you don't have two different numbers to work with, they're one number. And they did this on purpose, and the reason a mole is 6.02 times 10 to the 24th is because it makes these two numbers the same. The electron is practically 0 AMU. It's actually 1/2000, so you can ignore it because it doesn't change significant digits and all that. So that will not change that. So the mass number is the number of protons plus neutrons, and that is located, coming back up here, on the top left-hand corner. So here in this specific example, it's 17. That means 13. There's 13 protons and neutrons added together, there are 6 protons. 13 take away 6 means there's 7 neutrons. So you can calculate how many protons, neutrons, and electrons there are from this. Now, the reason why the mass number doesn't equal exactly the periodic table is because the periodic table the decimals on the periodic table is the average mass numbers of all the isotopes of the naturally occurring isotopes. Y is chlorine 35.5 on the periodic table if they only come up with whole numbers. It should be chlorine is 35 or chlorine is 36 because they go up by 1 ANU. How can this be 35.5? You can't have a 0.5 neutron. So what it is an average. It's just like the average American family is 2.3 kids. You don't have a 0.3 kid running around. It's an average. The averages can be decimals. It could be 50% are 35s and 50% are 36s. If you do that, they would average out to be 35.5. In real life, it's 75% isotope at 35 and 25% 37. How you do that, we'll figure that out on the next lesson. So the average mass number is not the mass number. This is for one isotope. This is an average of all isotopes. And that concludes this lesson on parts of the atom.